So, hello, thank you for coming. I'm going to be talking to you today about a bunch of different things that we're working on around the issue of how do we make sure that information systems, the systems that mediate our access to the information that's out there in the world, actually support human flourishing. There's a lot of big questions in that. I'm going to be talking about a few of them. With the systems that we're talking about, we're looking at the issues around, so we got a lot of different information, maze of twisting bookshelves all alike. And there's a lot of books there, and I don't know what I'm going to need. It's helpful if someone can say, okay, here are some books that are going to come solve your problem. They're going to help you learn the thing you want to learn. They're going to be interesting to you, etc. And so we want to, the systems that do this, that whittle down this vast quantity of information into a few things that are going to be relevant to you, whether they're based on a search query, whether they're based on your historical preferences and reading patterns. These are the kinds of systems that we're concerned about. My collaborators and I have started using the term information access systems to talk about these kinds of systems in a broad sense. Because there are a lot of overlaps, especially when we're trying to understand the human impact of these systems. There's very strong overlap between recommendation, information retrieval, and any other kind of data-intensive system, usually employing some machine learning, that is providing people with access to information. These are usually used to help people navigate, find things, discover new things in very large information spaces. Not always very large, but oftentimes quite large information spaces. And we want to understand the impact, the social effects, et cetera, of these systems. So they group together recommender systems, information retrieval, and similar tools. The question that keeps me up at night is, are these systems that we build, we have Google, we've got your recommendations in Netflix, are these systems good for all the people they affect? There's been a lot of work of, okay, how do we deliver recommendations that are going to be interesting to users? How are we going to get recommendations that are going to get users to buy more of our product? We've been working on that for 25 years. But how do we understand in a broader sense what these kinds of systems are doing to us? And not just doing to their users, but doing to the other people involved in the system. So I logged into my Goodreads, and I went to the recommendation page, and it said, here are some books you might like. There's a lot of questions we could ask about this. Are these recommendations good for me? Like, are these books I'm going to like? I can see why I would recommend them based on some of the other books I've read. When you read The Color of Law, Just Mercy probably makes sense as a related recommendation. But one of the questions, the classical question that we've been asking for 25 years is, are these recommendations good for me? Am I going to like these books? Are these relevant? Are these going to keep me engaged with the system? Are these going to help me find more things to read? Maybe are these going to help me read more books? But there's another set of questions that we can ask. How did these books get to be here? Was that process fair? Did relevant authors have a fair chance to show up in this recommendation list? Because if I'm using this recommender system, I'm like, oh, I'm looking for a new book to read. Okay, there's only 5 slots here. Not everyone can show up in my recommendation list, and we don't want everyone to show up in my recommendation list. That's part of the point. But if you write a book and you never show up in anybody's recommendation lists, it's going to be hard for people to find your book. So are these slots, we can think of these slots as resources. Are these slots, these opportunities to have your content put in front of me when I'm looking for a new book, are they allocated in a way that's fair? What does that question even mean? That's one of the key difficulties around here, is first figuring out what the question means. These systems show up everywhere. Most of us probably use search engines many, many, many times a day. And what we see when we type in a keyword of the available documents is filtered through that search engine's algorithm. It affects what we see. It hopefully helps us find the information we need, but it also affects our perception of what the set of information resources relevant to this document is. They show up in lots of other places. It's difficult to use the web for more than I don't have data on this, but I'll say more than about half an hour without encountering a recommender somewhere or another. Free study idea. How many recommendations does the average user encounter in a half an hour of internet use? I don't know. I would love to have a number on that. I approached this question, I'll get philosophical for just a moment. I approached this set of questions from a school of thought that I didn't know how to name until about a month ago. When Ben Green and Salome Villoin published a paper calling for a line of work they called algorithmic realism. And what algorithmic realism means is that studying these algorithmic systems, machine learning systems, recommendation systems, information retrieval systems, not in terms of their formal properties. I have a bunch of input data. I've got a stochastic gradient descent model that's going to minimize this function. What does that mean? But studying them in terms of what actually happens when the real system meets real data from real people. And looking at these emergent properties that come about from artifacts and biases in the data set, from imperfections in the algorithm. Our algorithms are trying to find patterns in the data. They do not do this perfectly. Some of that imperfection may harm their ability to do the job. Some of that imperfection may be useful in that they failed to pick up on a pattern we don't really want them replicating. If you've got a data set with a lot of racial bias and your algorithm's pattern matching algorithm isn't good enough at finding patterns to find that pattern, that might actually be a good thing. The key issue here, though, is that these systems are trained on data and they repeat their data. They repeat the patterns that we find in the data. A quote I like that captures this well is that machine learning is like money laundering for bias. You stick in all of this social data, all of this human data. We go and we click on search results. We read news articles. We read books. And all of that activity comes with all of our kinds of biases as humans, some of which are fine. We're going to be biased towards books we think are going to be interesting and relevant. The recommendations, Goodreads recommendations should be biased towards books I like. Like, that's the purpose of it. But those aren't necessarily the only kinds of biases that creep into these systems. And so we want to understand practically when we're applying these algorithms to real data, what happens. So we want to prevent this. This was an article. If you aren't familiar with ClickHole, it was a spinoff of The Onion, completely satirical BuzzFeed equivalent. But that the 50% of workplace discrimination will be automated. So our systems are learning they're learning from us, and we aren't always the best teachers. We don't necessarily want our systems to learn everything from us. So why do we care? We might just care because we care, but also this level of care is enshrined in some of our professional organizations. So the Association for Computing Machinery has a code of ethics and professional conduct. And it has many points, but some of them that particularly motivate a lot of my work are that as computing professionals, we should contribute to society and human well-being, and we should recognize the multiplicity of stakeholders. Not just focus on one set of stakeholders in the system, but instead, like, authors have a stake in what happens when their books, whether the books get surfaced or not in a recommendation system. We should avoid harm. We should be fair and take action not to discriminate. And one of the other things, when you go and you look into the details in the code, it talks about, particularly around avoid harm, that it's not enough to not deliberately design a system to harm, but that harms can arise from well-intentioned systems where we don't anticipate all of the emergent effects. And it articulates a positive responsibility for computing professionals to be proactive in thinking about the kinds of harms that might arise from their systems. Identifying them, seeing if they can figure out how do you test whether that kind of harm is actually happening, mitigation strategies, et cetera. But the code does not give an out of, we had no idea and we didn't intend harm. It articulates a positive responsibility to be proactive about considering the kinds of harms that your system could have. So if you're a member of the ACM, you've agreed to this. One of the reasons I'm happy to be a member of the ACM is this was overhauled a couple of years ago, and I think there's a lot of very good things in the new code. But thinking more about these stakeholders, we've talked about the users. I want to get good recommendations when I go to Goodreads. We talked a little bit about the authors. The authors want people to find their books. They read them, they buy them, their publisher gives them another book contract. There's a lot of other stakeholders as well. Booksellers, they care about the recommendations, so people will come and buy more books from them. Many of the entities involved have shareholders. They have an interest in their companies doing well. Publishers have an interest in their books being surfaced and being read. And publishers and authors are both on the creation side of the book, but of the book market, but their concerns are a little bit different. If a publisher has an author who bombs, that's fine, they expect that. They don't expect every author that they publish to succeed, and they manage a portfolio. As long as their portfolio has enough successful authors, the publisher's good. But that risk hits much harder on the author themselves. If nobody reads their book, they don't get their book in front of people. So, and then finally, the information we consume, both in books and more broadly, it affects what we know about the world around us. It affects how we understand and how we relate to the people around us. And so society and the way that we engage in society is the stakeholder in our information access, because of it has these broader impacts of how we go and we engage in the various processes in our society are affected by our information. So there's a lot of questions around what it means for things to be good for everyone they affect. Do we meet user needs? Do we respect user agency? Do we treat people fairly? A lot of different questions. As I said, though, one of the key questions is how do we even measure some of these things? And a lot of my contributions are methodological. I think of myself often as a methodologist. The long-term impact of my line of work I expect to be more how I measured the things I care about, how I measured whether a good book recommender is fair to book authors, than what I found precisely about some particular algorithm in some particular data set. The algorithms, the data sets are changing. The methods are hopefully reusable from one system to another. So I spend a lot of time thinking about how do we actually measure these things. Unfortunately, when you are a methodologist, and it's easy to get lost in the weeds because there's a lot of details. And understanding where the methodological problems are and working out the solutions requires a lot of details, and it's very, very easy to get lost there. So what I'm going to be doing as I get into the bulk of the work is giving you a very high-level overview of this work. There are many, many details I will not have time to get into, particularly in enough of once you start on one detail, you need 5 more to understand it. We're going to stay at a relatively high level for most of this. Also, for those of you who are students looking at coming to the seminar, seeing the different talks, you're seeing a variety of different kinds of talks. 2 weeks ago, we saw a talk that was very down in the details of the math that they were doing for the least squares solutions for robotic manipulators. This is almost the opposite of that. These different talks have different kinds of places. The talk I'm giving you today is the kind of talk you probably won't give very many of these until about 3 to 5 years post Ph.D. But it's good to see a few of them so that you see, okay, what does it look like when we're trying to talk at a high level about a broader set of work? So think, when you're in these talks, don't just think about, okay, what is this talk telling me about its material? Think about, what is this talk telling me about communicating research? What worked, what didn't? When might I give this kind of a talk? So, really, really brief overview of how these systems work. We have items and we have users. So items are the things that we're going to recommend. They might be documents, they might be books, they might be products on Amazon. Items are anything, almost any physical, or almost anything you can sell. And the users, they buy things, they read things, they rate things. And then we have ratings, which are some encoding of user preference of items. And we often use a shorthand. We'll call anything that indicates user preference on item a rating, even if it's not actually like a 5-star or a thumbs up rating. Sometimes we'll call implicit feedback of you bought something. You didn't say, oh, I like this item, you just bought it. Sometimes just for shorthand, we'll call the data that arises from that a rating. But you've got users and items, and the users take actions with items that indicate their preference. We then mine these, got a huge data set. We mine these with various techniques in order to come up with recommendations we present to the users through some kind of a user experience. The user does something with them that feeds back into the data for the next round. Hopefully the user is happy. A lot of the ways we do the family of algorithms that I work with the most are a family called collaborative filtering, where all we look at is user item interactions. And sometimes we look at them user-based. We say, okay, this user likes 3 things. Here's this other user who liked 2 of them. And this other thing they liked, maybe the first user would like it too. That's user-based collaborative filtering. We can do item-based recommendation where the user likes 3 items still. Here's this other item that's similar to 2 of the items that they like. It might be similar because a lot of the same users buy the items together. It might be similar because it has similar content. Like we've done a content analysis. It's a news article and it has similar content or it's about similar topics. We've got the similar item, and so we're going to say we're going to recommend items that are similar to the ones that the user has liked in the past. We can do various statistical models. One common one is a latent feature model, where we learn these intermediate hidden values that we use to explain, oh, the user likes these 3 items. Well, that's because they like these 2 latent features. And there's this other thing that has one of their latent features, so we're going to say they like that. Matrix factorization is the common framing of this one. And then once we have these systems, we have a variety of ways of knowing how they work. We can do a machine learning style evaluation where we take a data set, we split it, we see how well we do on the test data. We can throw them at users and see what users do. This is the gold standard in industry. You have a new idea, you give it to starting with like 1% of your users and eventually maybe half of your users. And you measure, do users with my new recommendation algorithm watch more videos than the ones with the old ones? If they do, good. Assuming watching more videos is what you're measuring. You have some kind of a measurement you care about. You can also do lab-style user studies where you actually ask users, what do you think? Companies do this a little bit with like those one-question surveys. You might get something pops up. What do you think of these search results? What do you think of these recommendations? But the A/B testing is used a lot more in industry. This shows up a lot in academia when we're trying to understand, particularly psychologically, how do people respond and react to recommendations. So, with that preliminary, users. Start by focusing on the users. One piece of work we did looked at starting with some fairness for users. Do different groups, so you've got a system, it's going to recommend movies or it's going to recommend music. Is everybody getting comparable quality of service, quality of recommendations? Or is it systematically giving better recommendations to some of our users than to others? That's the key question here. And so we did an offline evaluation, and here's how one of those protocols works that I just mentioned as ways ways we can measure the recommender effectiveness. So we have a bunch of ratings, and we split it into some training data and some testing data. Done any machine learning, this is a pretty standard process for you. We then train our recommender on the training data. We generate recommendations, and we compare them to our testing data, and we use that to measure how good the recommendations were. And what we found when we aggregated the recommendation quality measure by gender, we had 3 data sets for which we have the user's gender. Last.fm, so LFM is Last.fm. This is a data set that's a few years old, but it's from the Last.fm music listening system. And then we have data from the MovieLens movie recommender. And in MovieLens, men receives higher quality recommendations as measured by this experiment than women. For the music data, women received better quality recommendations than men. The gray one was not statistically significant. So we have a significant difference in the quality of recommendations for different groups of our users. When we looked at it by age, a big data set of user music profiles, we saw differences in providing worse recommendations to people in the 25 to 45 age range and better recommendations to younger and older listeners. Do we know why? Not yet. One of my master's students is working on that. But we found these differences we found systemic differences that were statistically significant in performance between different groups of our users. Not all users are going to experience the system in the same way. In a lot of our evaluations, we're going to go look, let's just average over all my users. I'm going to measure my recommendation quality. Maybe it's going to be online. I'm going to measure how many of my recommendations people actually click, yeah, I want to read that book. And we just say, okay, we're going to look at our click rate over all of our users. Okay, our recommender's doing better or worse. But what that analysis misses is not everyone's going to experience it the same way. And are there systemic differences in how users experience the system? Are there groups of your users that are never getting book recommendations they actually want to read? And is there something you can do about that? The call to action we had in this paper is go do this kind of an analysis on your system and measure and see what is happening. And then decide if what you see is consistent with your business goals. Like, do you want to have a system that has this kind of a disparity? Also, like, we could try to solve the system. We'll just make it worse for the group that it's performing better for. Probably not the solution. What you can do, though, is you can use results to prioritize development. If you've got a list of possible issues to work on, and you can identify, this issue, that's causing a problem for users that our system's producing worse results for, maybe prioritize that issue over one that's going to make things a little bit better for people who are already getting pretty good service from the system. In terms of operation, how would you act on these results? As we've been thinking more about the implications of them, that's where we've been landing, is think about them in terms of feature prioritization. But we have these metrics. We can also, one of the other things that we've been looking at is there are a lot of problems in these metrics. So if I've got this recommendation list, 5 movies, I can compute some metrics. One of them is reciprocal rank. Where is the reciprocal of the rank of the first relevant item? The Iron Giant's the first relevant item. Okay, reciprocal rank 0.5. We can measure metrics on this list. But in reality, we never have that data. In reality, we recommend some movies. We know I like some of them. We might know I don't like some of them. And we don't know for actually most of the movies. So what we do is we assume unknown is irrelevant. We compute the reciprocal rank. And so we say, this is 0.5 because the first relevant movie is in the second position. Okay. But if I would like Zootopia, and I haven't rated it, we have no record of me having watched Zootopia or liking it or anything. But then it's a good recommendation, possibly even a better recommendation. If we've got the data, yeah, you like the Iron Giant. We have that data because I watched it. Somehow I found out about the Iron Giant and I watched it. We have no data on Zootopia. If I would actually like Zootopia, and our purpose is to help me find new things, it is a better recommendation than the Iron Giant because, okay, I like both of them, but I didn't know about Zootopia. But the evaluation metric says, nope, bad recommendation because we have no data. We're going to assume it's bad. Most of the time that assumption's false, but when it's true, it means we're penalizing this algorithm that's finding the best recommendation because we can't distinguish the best from bad. So this problem has been known for a while, but how bad? Not so known. My master's student who finished last year did this work for his thesis, and we're going to be presenting it at the Computer Human Information Interaction and Retrieval Conference next week, assuming it still happens. So if we had the true preference values for all of the movies, if we knew whether a user liked every movie, if we had those, we would just recommend the stuff they actually like. We wouldn't need all of this machine learning. And they also probably don't exist for psychological reasons. But if we assume that they do, this also causes a problem if we're trying to measure, say, how much exposure does a book deserve? Like, should I recommend a book to you if we're trying to measure, do authors get fair exposure in the recommender system? We wind up with this problem a lot because we don't know whether the user is going to like most of the books. So what we did, so we take this protocol. What we want to do is so we have these consumption records, we have the ratings. We just assume that they came from that they're observations of some underlying full set of preference data. But we don't have that full set of preference data, and we can't get it from the ratings. If we did, we would have a perfect recommender, or the buildings of a perfect recommender. So what we do is we turn it around. We make up a bunch of full preference data, and then we simulate observing ratings from them. So we simulate users like movies, users rate some movies that they like. We then run this synthetic data through our pipeline, and then we can compare how does a recommendation from what we would do with the observable test data, how does the results of that compare with what we would do if we had access to this full data. Now, because all the data is synthetic, this does not give us a way to evaluate an actual system with actual data, because we're completely making up our users and our items and what they like. What it does let us do is it lets us start to test the bounds of this process. And if we test with a range of assumptions of how the data generation process works, then we can understand, well, how often do we have this kind of a missing data problem? And how much does that skew the metrics from running our experiments? So we derived several different models. We calibrated them to match characteristic statistics of publicly available data sets to generate data that looks realistic. And we ran the experiments, and we found key findings were, for many common metrics, effect sizes, where the effect size is how well your new algorithm beats a baseline, were severely misestimated. Most of the time, it would put them in the right order. However, that most of the time were on the data sets that are the most common, but also the least realistic in terms of what actual user data you would have in a production system looks like. The most realistic data we tried to simulate consistently got the algorithm order wrong. What we did, we simulated 3 algorithms. A popular algorithm that just recommended the things that were most popular in the rating data. A random algorithm that just picked random things to recommend, and then an optimal algorithm that used this synthetic full preference data to know exactly what the user would like and recommend the stuff they liked. On the most realistic data setting, it consistently thought popular was better than optimal. So this missing data problem is causing a significant problem in the assessment of these systems. Unfortunately, we don't yet know how to fix it. That's future work. But we have numbers now on how often this is driving our experiments to produce incorrect results. So for users, we're looking at how do we measure accuracy accurately? And who gets how much of this accuracy or how much of this quality? But if we shift from users to thinking about users not just as passive consumers of the system, but giving users agency in the kinds of systems that we're building and using them and designing them and evaluating them. We're working on another project that looks at, one of its key motivating questions is, can we empower experts? A lot of times, like, oh, we want to make a recommender system to find books, so you don't need to go to the library. What if we make recommender systems to make librarians more effective? Make the expert more effective at their job rather than replace the expert. And so we're working on a project that is trying to help teachers find readings for their students. And so we've interviewed some teachers to understand how they're currently looking for readings. And common theme is that teachers want to incorporate, we're looking at K-12 teachers, want to incorporate more readings into their classrooms to help their students engage with the content in a broader way. But they're hard to find good readings, and they don't have a lot of time to go find them. So there's a lot of challenges in trying to find a good reading for a classroom. It needs to be appropriate to the age of the student. If you give a kindergartner a scientific paper, it's probably not going to go very well. It needs to be relevant to the curriculum that you're trying to teach. It needs to be pedagogically useful and promote learning. And it needs to keep students engaged so they don't get bored and just want to run away from the reading. How do you pull all of these things together? This project is very, very early stage. But we want to support teachers in meeting students where they're at, finding readings that are going to connect to curricular needs and support literacy and civic awareness, as well as learning the topic that we're currently trying to teach in the class. So we built a system, a minimum viable prototype, that lets teachers search for news articles and filter them down by some pedagogical constraints. It then presents some information about the article that helps them assess its usefulness. If you click more info, you'll see like how long the article is, how many images it has, etc. And we've run a user study for this that we're currently revising the paper for. Teachers generally have been positive of this kind of system. A few things, though, that we found is that when we were interviewing teachers initially, experienced teachers were more likely to be supplementing their curricular material with original sources. Newer teachers were more likely to just stick with the curated sources that were readily available. Google was not good enough for finding these kinds of resources, but also there is very, very high teacher turnover. Not very many novice teachers last to become experienced teachers. And so the set of teachers that are engaging in this level of activity is small. Can we build technologies that allow the novice teachers to do what the more experienced teachers are being more effective at? When we brought teachers in, though, one of the key things we found is there's a huge gap between what you're looking for and what you might actually be able to find, especially if you're trying to find like a news article to supplement a reading. You type linear equations into Google News, not going to find very much that's useful for teaching your third graders or sixth graders about linear equations. And so there's this significant gap between the topic matter and then how you're actually going to be able to find readings that are going to be able to support this kind of work. Also, there's an issue of how do you surface what's going to be useful in a reading. We've got this article about gravity. There is in there, it has Newton's law of gravity and discusses what that implies for this story about space travel. But it's about 75% of the way through the article. It takes a lot of time to get there. How do we surface, oh, if you're teaching about Newton's law of gravity, this article connects it to a current story. How do we identify that that's happening in this article and make it easier for teachers to come to that judgment with very, very limited time? We don't know yet. But shifting on to not just the users and then trying to give them agency, but looking at the subjects of the recommendations. The book authors, the topics of the books. We've talked a little bit about fairness in terms of we want to provide users with comparable quality of service no matter who they are. That's one kind of fairness. But there's many other senses of fairness. And we've been thinking a lot, my collaborators and I have been thinking a lot about this question of what does it mean for an information access system to be fair? We just submitted a proposal for a 100-page paper on this question. And there's a lot of work on fairness in machine learning, but a lot of those answers that have been developed in the general machine learning setting don't apply to information access for a variety of reasons. Information access is multi-sided. You have users, or consumers, information consumers, and you have information providers. Almost none of the fairness in machine learning literature deals with that kind of a problem setting. It's personalized. If you've got a loan decision-making system, you don't want the loan like when the banker asks for a creditworthiness score for someone applying for a loan, you don't want to personalize that score to which banker is asking for it. You just want to score based on the loan customer. But we do want to personalize. We want to compute whether this book is relevant to me, and that's going to be different than whether it's relevant to you. So you have this personalization level that a lot of the existing research does not consider. It's also repeated. We're recommending this. We have this opportunity to recommend the same book over and over. Someone might apply for multiple loans, but they're probably not going to apply for 1 million loans in a day. Goodreads probably has 1 million opportunities to recommend a particular book in a day. And it's also complicated. We're working out some of those details. But when we think about what is fair, there's a variety of different ways to break down what is fair. Kate Crawford, in her keynote a couple of years ago, talked about two broad categories of harms that unfairness might induce. And one is distributive, which is how are resources being distributed? So that resource might be quality of service. I get information that's relevant to my needs. That resource might be the opportunity to have my documents show up in search results or show up in recommendations. Are those resources being allocated in a manner that is fair? And then there is representative harms, which are when the system is negatively or unfairly representing me in some way. A very clear one is misgendering, but there's many other ways. Is it representing me in such a way that's keyed off of some stereotype? And so it just makes a stereotyped assumption on me and generates recommendations. It says, oh, you're a white guy from Minnesota, therefore we think you're going to like these white guy from Minnesota things. And just building in these kinds of stereotyped representations is another way we can have representational harm. So another way we break it down specifically from information access, you remember our stakeholders, we can think about consumer fairness and producer fairness. We can also think about fairness for other stakeholders. That's not as well developed yet. The work I was showing you where we were looking at the disparate quality of service, that was a consumer fairness problem. We were looking at, are we treating different users of the system in a fair fashion? We can also look at provider fairness. And then we have a lot of questions of what does it even mean to be fair? Do we want the recommendations to be representative of the broader world? So when you type in a query into Goodreads, do we want the results to represent what the space of books on that topic is? Is that fair? Or do we want the results to represent what the space of authors writing on that topic is? Do we want the recommendation to provide equal opportunity to authors and content producers? Do we want the recommendations to accurately reflect the user's preference in some way? Do these compete? This is a new and a young field. A lot of the questions are very, very, very young. We don't know how to measure a lot of this. I'm going to skip that one for a moment because I'm running low on time. So one project we have done on this is trying to understand how author gender is represented in book recommendation. So we have a large data set that was harvested from Goodreads that contains, so we have Goodreads, we also have Amazon book ratings, and we have book ratings from this old site called Book Crossing that's been used in a lot of recommender systems research for the last 15 years. And so there are efforts to improve representation of various underrepresented groups in book authorship. Wanting to see more books written by women, wanting to see more books written by various ethnic minorities, etc. And so the Canadian Women in the Literary Arts Organization, they do a census every year of the books that are reviewed in Canadian literary publications by gender of book author and gender of book reviewer to see numerically how is Canada doing in its literature industry on gender representation. So the question I have is, what is the recommender, how is the recommender affecting this effort? Suppose we do have a good effort to get a lot more authors of a particular underrepresented group writing books, and they get their first book contracts. And then their book goes up on Goodreads and Amazon, and it hits a recommender. Does the technology I've spent my career teaching people to building and teaching people to build, is it helping that author find the audience that's going to make them successful? Or is it getting in their way and just reinforcing the status quo and saying, oh, everybody just wants to read the authors they've been reading? We don't know. Algorithmic realism, we don't know what it actually does. We can hypothesize. We have a pipeline. There's a lot of books that exist in a corpus. Amazon sells a lot of books. A user has some books. And then from those books, they get recommendations. And we want to look at each stage of this. How is gender represented? The way we're operationalizing that is the percentage of books written by women. And so from a normative perspective, one of the things when we're trying to work on these social impact things is it's important to be clear about our normative frame. And by that I mean, what are the moral claims we are making about the world and about our solution in which we are grounding our work. Because we can do a lot of technically interesting things, but if we're not clear about what harm we're trying to address, it's difficult to know what to do with them. And so what we're doing, the framing of this problem is that a fair recommendation provides a good representation of the goods of the book space. If there are a lot of books written, like basically the proportion of books written by women should be representative of the broader population of authors or the broader population of humanity. Unfortunately, we don't have good reference points to know what neutral is supposed to be, so here we're just looking at what actually is it, but that's the high-level normative goal. Also, this is a provider fairness thing, but it also has, like we're looking at the authors, but it has consumer harms, because if you consistently just see books written by one group of authors in a set of recommendations, you don't know about other groups of authors writing books. And over time, it can skew your perception of what the space of book authors looks like. So we can look at the, if we look at the distribution of percent of books written by women in the Library of Congress, so of the books for which we can figure out their gender, a lot of details in the paper. Percentage written by women in the Library of Congress is about 22%. And Amazon ratings, it's higher, it's about 31, and then Book Crossing and Goodreads are closer to 40%. So women are less underrepresented in the ratings people are given than they are in the underlying, say, Library of Congress corpus of books. If our goal is improved representation, this seems like a good thing. We then generated recommendations for users and measured what the recommendation lists look like. And looked at we also looked at the profiles for the individual profiles for these 1,000 users. So that was like, if I just look at all of the ratings, what is the gender distribution? But now if I look, okay, each user, what's the gender distribution of their ratings? And I look at the average of that, it's pretty diffuse. Users are all over the map. The average is a little under 50% on each of these. We can then look at the recommendations. The averages are relatively comparable. I'm not showing them on here, but quantitatively they're relatively comparable. The variance is lower. Recommendations are more consistent than users. So if we take 1,000 of you and we look at your profiles, that's pretty inconsistent. If we take 1,000 of you and we look at your recommendation list, that's a little more consistent. Not surprising. Also, though, each of these collaborative filtering algorithms is propagating a fair amount of the user's preference or the user's patterns into the final recommendations. If you read more books written by women, you're likely to get recommended more books written by women. It's capturing the pattern, it's propagating it through. We don't make any normative claims about whether this is good or bad. Our goal here is to describe what is. Normative claims are going to come through working with the sociologists and the media studies people, probably. But this is one project that we did to try to do this. A bunch of limitations. Rating data extremely sparse. Both the statistical methods and the data are only considering binary gender identities right now. Working on fixing both of those. But our goal here and the way we approach this is, how can we use the data we have available to expand knowledge and work on the limitations? Like, we don't want to do things we know are bad or are deeply, deeply problematic, but we know there's going to be limitations to any of this work. So how can we use what we have, advance knowledge, make things better, and do that by developing methods that can be reused as we get better data? If we get a better data set that has better data on user gender, we have to fix a couple of the statistical issues, but we can rerun a lot of this analysis with new data. And others can rerun it internally. I know of a company that has been looking at trying to do this kind of analysis in their own internal recommendations. The question is, what do we do about this? Do we force a particular representation? We just say, oh, recommendation lists, they need to be gender parity. Well, is that going to meet user needs, and is that going to respect user agency? Do we do nothing? Is that going to perpetuate discrimination? Do we maybe just develop other nudges? We leave the core recommender alone, but we have books from new authors you may not have thought about. And so we put this other experience into it to surface books in a way that might compensate. We don't know which we should do. What we can do as data scientists is we can develop the tools that will let the policy and business decision makers understand how each of these scenarios is likely to play out. And when we're having these conversations, like, the data scientists should not be the ones who make unilaterally all decisions of what's going to happen. But when you have these conversations, we can bring the data to say, okay, if you want to make this policy, what's that going to do to our system? How do we measure what that's going to do to our system? And we can have this ongoing conversation. One of the challenges, though, is so far we're just looking at, okay, this distribution of the list. We aren't yet looking at how is opportunity to be recommended being distributed. Fortunately, there has been great progress being made on that in the last 2 years, by others mostly. So there's been look at work on list composition. In 2018, there was a pair of papers that were published, one by Ashdeep Singh and another by Ajay, that made substantial advances in how we can actually try to measure what it means to be fair to authors. And they said that the attention an author gets from the recommendation by appearing in good spots in the list should be proportional to the relevance of their documents to query. So if you write documents that are relevant to people's information needs, you should be able to show up in recommendation lists. And we shouldn't have this rich get richer where someone's writing a document that's 2% more relevant than yours and is getting twice as much attention. That was a significant advance in understanding how we can actually define the set of problems. There was another advance last year that looks at pairwise ranking probability in terms of fairness. I don't have time to get into the details to it, but we've seen some really significant advances in the last couple of years. And how do we actually even try to measure this kind of problem? We're working slowly on trying to figure out how to pull these advances into what we're doing with the book recommendation work. Lastly, to close out the little theme, been thinking a little bit about fairness and privacy. So we have privacy, there's a lot of interest in privacy. Okay, we want to keep people's data protected. But is that privacy system fair? Are some people getting better protection than others? Is that fairness does disparate privacy fall along, or historically disadvantaged groups also not as able to take advantage of privacy protection schemes? So we proposed a definition that a privacy scheme is fair if the probability of failure and the expected risk from this from privacy failure are independent of subject membership in a protected class. Just one possible definition, but we put this forward as a possible definition of what it would mean for a privacy system to be fair. So the privacy system does not protect members of one race more than it protects members of another race or of another gender. People have taken this and variants of this and gone hunting and found disparate privacy in a variety of systems. It's been fun to see that work show up. This was a position paper call to action. There's a lot of questions. Do privacy protections provide equal protection to all their subjects? Is it easier to breach the privacy of a group that's already vulnerable for other reasons? There was an example of, there's a data set of New York taxi cabs and trips, start, stop, route. So you've got all this data. You cross-reference this data set with mosque locations and prayer times. You can identify the Muslim drivers. Now, you can't do that kind of attack against some of the other groups of drivers, but you can say, oh, this is the set of Muslim drivers in the data set. So you have this privacy attack that's possible against one set of users and is harder against other sets of users. Is that something that we as professionals and we as a society find acceptable? So that's what keeps me busy and keeps me up. I'm happy to take questions. There's a lot of deep questions, both in the technical side and on the, like, how do we do the work? How do we do the interdisciplinary conversations needed in order to make this work? The community that I'm doing this in, the fairness, accountability, and transparency community, is deeply interdisciplinary. We have law scholars, policy experts, sociologists, anthropologists, critical theorists, you name it. There's probably somebody there. few groups that might not show up. How do we actually have that conversation in a productive way, particularly across sometimes very, very deep epistemological games?